Today we will be solving a College Board AP Chemistry free response question from the 2002 exam Form A. We will be solving question number 7, and we will begin now. An environmental concern is the depletion of O3 in Earth's upper atmosphere, where O3 is normally in equilibrium with O2 and O. A proposed mechanism for the depletion of O3 in the upper atmosphere is shown below. A. Write a balanced equation for the overall reaction represented by step 1 and step 2 above. Since catalysts, species that are apparent in the reactant of step 1 and the product of step 2 are canceled out, we can cancel out Cl from the overall reaction. And since intermediates are also canceled out, which are the products of step 1 and reactants of step 2, we can cancel out ClO. Therefore, that leaves us with O3 plus O yields 2O2. B. Clearly identify the catalyst in the mechanism above. Justify your answer. The catalyst is described as a species that appears in as a reactant in step 1 and a product in step 2. Therefore, Cl is the catalyst. So, Cl is the catalyst. Because it appears as a reactant in step 1 and a product in step 2. Now you always want to remember, catalyst, reactant in step 1, product in step 2. Alright, now C. Clearly identify the intermediate in the mechanism above. Justify your answer. Since the intermediate is described as the species that is apparent in as a product in step 1, and then is used as a reactant in step 2, we know that ClO is the catalyst. So, ClO is the, we know that ClO is the intermediate. Misspoke there. ClO is the intermediate because it appears as a product in step 1 and a reactant in step 2. And whenever you see the word intermediate, you want to associate it with product in step 1 and then the fact that it's used as a reactant in step 2. Alright, D. If the rate law for the overall reaction is found to be rate equals K times the concentration of O3 raised to the first power times the concentration of Cl raised to the first power, determine the following. The overall order of the reaction. Since the overall order is found by adding the exponents of the concentrations in the rate law, the overall order of reaction would be 1 plus 1 equals 2. Second order overall. Alright. And we'll box X, that's our answer. Appropriate units for the rate constant, K. Since rate equals K times the concentration of O3 raised to the first times the concentration of Cl raised to the first, we solve for K, which brings us to K equals the rate divided by concentration of O3 raised to the first power times the concentration of Cl raised to the first power. And we know that the units for rate are molarity times time raised to the negative first over, and then we find the units of the denominator, which would be molarity squared, because both concentrations have units of molarity and they're multiplied together. Then we solve, we can cancel the m from the numerator, which makes the m in the denominator raised to the first power. Therefore, that brings us to t to the negative first over molarity, which is equal to m to the negative first times t to the negative first, which can also be written as 1 over molarity times time. And we'll make that like that. And we can box that because that is our answer. Alright, now the final part of this question. I'm sure you're ecstatic at this point. Stop hearing me talk and get this over with. Alright, the rate determining step of the reaction along with justification for your answer. Now we know that step 1 is the rate determining step, also known as the slow step, because the reactants of step 1 appear in the rate law equation. So we'll write that down. Step 1 is the rate determining spell that wrong. Determining step because its reactants coefficients correspond with the exponents of these species in the rate law. And that is the other thing, you must make sure that the reactants in the step, their coefficients correspond with the exponents. So, since they both have 1s for coefficients, they do in fact correspond with the exponents, and it does work. So that's it. Good luck on your AP test in May, and there you go.